And we should be live. Welcome everyone to another live stream repair. We've got 1, 2, 3, 4 HomePods in for repair today. Hope you all had a wonderful Thanksgiving. I sure did. Wife whipped up the best ham I've ever had in my life yet. And I don't even typically enjoy ham that much, so it was real good. So, first up here, let's go ahead and update the text on our screen. First one is up from Evelyn with no power. And then we're going to move on to Yottaman. I don't actually know what their name is. That's just part of their email address. They've got death farts. And then we've got Damon, whose HomePod turns on and seems to work fine and then shuts down all on its own. And then we've got someone whose I've not yet identified, but I think it's got no power. So, let me double check my emails, make sure there's nothing new there. Alright, we're ready to start. So here is Evelyn's with no power. They had already tried getting into it before, and they managed to get the plastic cover off, but they didn't. Doesn't look like they quite got the display here off. So before we go any further, we're going to go ahead and just double check their symptoms here. We've got a power cable. We're going to plug that right on in and confirm that we've got no sign of life there. And our watt meter says that we're pulling about 4 watts from the wall. So that's well within the expected range of what we see when this most common failure mode occurs, which is that diode on the amplifier shorting out and causing that no power. So we'll just take that top off there. We're going to grab our Jimmy tool and finish getting that display out. And then we will work on this frame. Get that logic board out of here. And then we can pull that mesh down, get these screws uncovered. Work on those. Before we pry this off, we don't want to forget to detach this cable here. Make sure there's no strings attached. And now we can pry. think we've got that loosened up enough. Oh yeah. Very nice. Very nice. So with the hard part over with, let's get ourselves a drink. And carry on. Get that subwoofer out. What do you want, Atlas? Atlas. 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 I don't know if you guys can hear the cat. Atlas. Yeah. Alright, it's time for a woofer check. Voice coil looks really good. Feels nice and smooth. And it smells like a happy subwoofer. Let's go ahead and get that ribbon cable pushed through. And we will get these out. There we go. Now when we go to put our basket back down, that'll sit more evenly. There's a little bit over here to cut off. Alright, that should do. I'm just being picky. Let's get this power supply. Be free, little amplifier. Yes. Alright, what have we got here? We've got a rather roasty looking Schottky barrier diode right here with a date code of 1746K on it. So I think we all know what to expect when we go to test that. Everything else looks all right. So let's go ahead and get up close with that diode. Looking good. Oh, I didn't even test it. Let's go ahead and test it real quick. Yep. She's dead, Jim. There we go. We'll go ahead and put that into our dead pile. If you were curious, these are all of our diodes here that we've saved throughout all of our repairs. These are all of the dead ones. These are all of the ones that were still working but we replaced anyways. And then these are brand new ones. So just to give you a rough idea, the ratio of failures with these diodes. And also the fact that every single one of these dead ones have date code 1746 or 1748K, whereas all of these other ones that we pulled off and replaced that were still working, some of them still have those date codes, but most of them have date codes much older or newer. So, coincidence? I think not. But for now, all we've got is a coincidence. Let's grab a new diode, get it prepped and put onto our board. And when that solder melts, it should basically snap into place, but sometimes you gotta give it a couple of taps to do that. But there you go. Let's cool this off in front of the fan for just a sec, and then we will see if it's working. That should do. Now if we tested that diode and the diode tested good, then I wouldn't be using our power supply to test this. I would be using theirs because more likely their problem lies somewhere in their power supply. But we were able to confirm straight away that that diode was shorted out, which most likely is the source of the no power issue. So we like to use our power supply for testing. If I remember to use it, then I've got a little bit of the plastic cut out where the filtering capacitors are. That way, if it has any offset that warrants replacing those capacitors, I don't have to rip the power supply off and put it back on when we're done to give it another test. Just another way to be a little more efficient. So let's get our multimeter turned on to DC volts mode so we can check for any offset. And also based on the power draw, I know that it's probably not their logic board, so we're going to test with our logic board that's already got a display on it. If we only saw 1 or 2 watts of power draw, then I would be suspicious, or I would suspect rather, that the logic board was actually causing their no power issues. But we're going to go ahead and test with ours because again we confirmed the dead part on the board there. So let's see if this works. Yeah. First try. So, what do we got? And see, so we've got 80 millivolts of DC offset there, and it's growing. So that's enough to make me want to replace those filtering capacitors. So let's go ahead and do that really quick here. It's a good thing I kept I grabbed my test power supply here already, so that way that's already, see that right there? I just gave my own power supply a little cut there so we wouldn't melt it replacing these caps during testing. Into the graveyard for ya. You too. Okay, so DC offset is essentially unwanted DC voltage that your amplifier is producing and putting into your subwoofer. DC offset is basically just DC voltage, but it doesn't matter whether it's positive or negative. So it's just simply how far away from 0 volts DC you are. And in a perfect world, your audio amplifier would have 0 millivolts of DC offset whatsoever. If you didn't know, your analog audio signal is not DC, it's actually AC. Before I got into HomePod repairs, I actually didn't know that. I always sort of intuitively thought, well, based on positive and negative on the back of speakers whenever you're wiring them up, I always thought audio was a DC signal, but that's not the case. Audio is an AC signal. So what happens when you introduce DC voltage in your AC analog audio that you're feeding your subwoofer, or any speaker for that matter, it ends up moving that speaker in one direction or the other and keeping it there. And what that ends up doing is it puts the voice coil of the speaker under more load than it needs to be. Because it's not constantly moving back and forth, it's not giving itself a chance to cool down. So it's going to roast your speaker coil. It's going to put your amplifier under additional load because all the amplifier is supposed to do is amplify whatever it's given. The amp right here itself, this chip, it's not built to filter anything. It's just going to amplify whatever it's given, be it AC, DC, or whatever. So these filtering capacitors here tend to go bad over time and allow more and more of that DC voltage through the amplifier and then into the speaker. So that's why we've got our multimeter here connected to our subwoofers, so we can see how much DC voltage the amplifier is producing and spitting out to the speaker. Be it, again, positive or negative, it doesn't really matter. What matters is how far away from 0 volts we are. So, hope that makes a little sense. It's a pretty common thing in the audio industry, so if you want to know more information, I would always suggest searching up on Google more info about it. Alright, how's that looking? Is it looking funky fresh, or does it need another hit? Ooh, that looks real good. Damn. Damn. Okay. Let's cool that off here real quick. And then we'll see if we got rid of that offset there. So generally, we like to keep our DC offset on HomePods under 50 millivolts. Realistically, you're not going to cause damage to anything until you are around a couple hundred millivolts at the least. But anything past 50 millivolts is generally out of spec enough, in my opinion, that you can replace those filtering capacitors and you should be able to bring it down under 50 millivolts again, reliably. So we saw around 80 millivolts on yours, and it was still growing every second. So gave me enough of the heebie-jeebies to want to replace those either way. Alright, how are those feeling? Those are nice and cool now. So let's put our parts back together here and see if this is ready to go. All right. What do we got now? That's more like it. We're holding steady at around 10 millivolts now. So I'm happy with that. And the fact that they are fresh new filtering capacitors. They should last you much longer than those old ones were now. So let's get our test parts off here and put this back together. the heck? There we go. Whiff of thyme. Everything is nice and sealed, so we'll put our basket on now. Okay, how sticky is this still? Yeah. It should work. Looks like the top's got a little bit shining through there, but there's no part of the display that actually lights up there, so you're not actually going to see that shine through. But all in all, you didn't do too bad on your first try taking this off. Definitely looks a lot better than my first try. That's for sure. So let's get that stuck back on there. And boom, J-Rock, baby. Looking fresh. Let's power this up and see if we got everything ready to roll. Drum roll, please. Yeah. All right.
I'm having trouble connecting to the internet.
Very good.
I'm having trouble.
And very good. Volume buttons light up nice and even, and we've got nice bassy series still. So this one is all fixed up and ready for some action. I wonder if we can. Nope, that is definitely scratched. Dang. Okay. I was wondering if we were going to be able to clean that scratch off that they put on there, but it is unfortunately a little too deep. But all things considered, it looks really good. So we'll put that away. And let's find number 2. Okay. Let's get that beast of a box opened up here. It's another box. Hello from Prince Edward Island. Thanks for your videos. Managed to repair a couple of HomePods and recycle them. Yes! I love to hear it. These things are way too good to be thrown in the trash over $1 or $2 in parts. In an hour or so of someone's time. Here we go. Our next adventure. So this one's got death farts. Now, death farts are essentially this loud buzzing tone followed by a restart. And these happen when that DC offset that we were talking about in the previous repair grows so bad that the amplifier sees, whoa, hey, that's way too much DC offset there, bud. And it forces a restart, and it plays that death fart tone. So, most likely what's going on here, because they've got death farts, is those filtering capacitors have gone so bad that they've allowed so much DC voltage through the amplifier into the speaker, tripping that offset detection in the amplifier and producing those death farts. So what I expect to hear when this boots up and we bring it out of its default low power mode, I expect to hear a fairly loud pop. That would be a pretty good indicator that those capacitors aren't doing so well. Popping by itself as it goes in and out of standby here isn't by itself an indicator that your caps have gone bad, but sometimes you can use it to judge whether or not you've got a problem. So let's listen here.
I'm having trouble.
So I heard a decent pop, but I've heard louder from HomePods with fresh capacitors. Yeah, it's not the loudest pop. So as you can see, it's not the best indicator. It's not a guarantee that you have a problem, or it's not a guarantee that you don't have a problem. But it is sometimes a good indicator. So let's get this taken apart. We're gonna get the amplifier hooked up to our test woofer on the bench here with our multimeter. Before we do any repairs to this, we just want to get an idea exactly how much DC offset this amplifier is currently producing, just to confirm that's the issue, and then we will replace those caps and see if we get rid of that offset, which will almost certainly get rid of those death farts. As I always mention, we're not using this tool and we're not doing any prying in this step. All we're doing is we're going around and we're cutting through that adhesive, and it's going to take a few rounds to go around it, but we just want to cut that adhesive through enough until this pops off essentially all on its own there. And that's how you can avoid damaging it. You don't want to pry up against this. You don't want to try to peel it off, because that's how you bend it, crack it, scratch it up and such. But it also does take a bit of practice to get the feel for it. Let's get that back under control there. Yes. Yes. Excellent. Voice coil looks good, feels nice and smooth, and it doesn't smell burned at all, so that is a happy little woofer. All right. As I said, before we do any repairs to this, we want to go ahead and double check what's going on here. So we're going to power this amp up, plug it into our woofer on our desk here, and confirm with our multimeter that we do in fact have a large amount of DC offset that's causing our death farts. And then we will go on ahead and replace those filtering capacitors. While we're at it, while we're in here, we're going to replace this Schottky barrier diode here. It's just sort of preventative maintenance kind of thing. We don't know why these short out and fail and cause no power issues so often, but even if it's working fine and it's not within the usual suspect of date ranges there, we replace this diode in all of the repairs. So, and then we will see if we've got rid of our offset. Trying to get rid of that glare. That'll do. So what have we got here? Alright, so yeah, we've got about 230 millivolts of offset here, and it is rapidly growing. So that's probably going to grow past a few hundred millivolts, probably into like 2 or 3 volts DC, and then trigger those death farts. So we're going to get those caps replaced. See if we can rectify that. And there they are. Let's go ahead and pull those old ones off. Since there's no great way to test them in this sort of failure mode, we just go ahead and replace all 4 of them here. That looks fantastic. So we're going to replace that Schottky barrier diode now. Hi Brian, did you email me back? Cause I think you said you were gonna shoot me a new shipping address, and I never heard back from you. So if you haven't yet, go ahead and let me know that new address. Shouldn't change the shipping quote that I shot you yesterday or the day before. Mark asks, what do you charge for a repair like that? So pretty much all of our repairs are $60 plus shipping. The only time a repair is more expensive than that is if the bass speaker itself needs to be replaced. In that case, repairs are $80 plus return shipping. But pretty much the majority of repairs are $60 otherwise. Okay, let's get this diode replaced here. And if you were curious, it's got a date code of 1726K on it right there. So far outside of that usual suspect of bad range of diodes, but we're going to replace it regardless just to prevent that no power issue. You never know. Until you know. Easy peasy. We'll put that into the used pile. We like to keep our diodes here separate between the used ones that we've replaced and the ones that have that we found that are actually dead. Alright, let's cool this board off for a minute in front of the fan and then we will give it a test. That's more like it. 3 millivolts of offset there. Seems to be falling towards 0, which is quite an excellent score there, and a significant improvement from what they had before there. So they should no longer have any death farts here. For repairs like these, I leave them plugged into power overnight before shipping them out the next day, just to make sure that there are still no death farts or other issues that crop up. But if you get rid of that offset, then you'll get rid of those death farts. That's what causes them. If you don't have any DC offset, then it's not going to fart on you. That is its programmed behavior. And if you don't believe me, you can actually look up the schematic for the I can't remember actually if it was the AMP IC or the DAC. It was one of these two chips that actually has that behavior programmed into it. Which when I stumbled upon that, I thought that was quite interesting. But it makes sense. It helps you, kind of helps you identify problems without having to take it apart to know what's going on. And like, here's the thing. DC offset is inevitable with your audio amplifier. So what do you do about it if it's going to be a thing in every amplifier? Well, you have filters, and that's what those 4 capacitors that we replaced are supposed to remove. So if you have DC offset, your filters are bad, and there's only 4 of those caps in there that do that. So it's a pretty simple and straightforward diagnosis and repair. It's not the amp chip going bad or coming loose. It's nothing else like that. Drop the bass. Is it nice and sealed? Yes, it is. Hey, Damon. Glad you could make it. Yours is actually up next. What the heck? Malfunction. Oh, cool. I just got it, Brian. So I will get that packed up and shipped out for you to... Well, actually, I'll get it packed up for you today, and it'll get dropped off at the UPS store tomorrow. Or USPS, or whichever one you picked there. Alright. Get that up. Too far. There it is. We got him. how did you start up doing this repair? Well, it started when I just wanted to get my hands on more of them without spending a bunch of money on them. And I found that I could buy broken ones for fairly cheap. And as I was buying broken ones and fixing them, I noticed that all of the issues were fairly common. And there wasn't a whole lot of information around on how to fix them, let alone anybody out there actually offering repair services for them. So I saw that as a bit of an opportunity there. And I put myself together a website and started going around various social media forums like Reddit and Twitter, and basically just offering people free repairs if they cover shipping, just to get the hang of it, build up the confidence and experience to where I can actually justify charging people money for these repairs. And once I got to that point, we're here roughly a year later, and yeah, it's going pretty well now. We get on average upwards of 5 to 6 a day now. I also it seemed like a really fun challenge to figure out exactly where these issues were coming from and how to repair them, because unlike a lot of other products out there, there's schematics available out there for other shit. There's usually more people like actually covering repairs and putting info out there, but there wasn't anything like that for the HomePod. So I saw a place where I could potentially, make a name for myself. Save a few speakers from going into the trash, because I probably wouldn't have started up a business like this over just any product. I really, really love my HomePods, and I love them so much that I want to fix them for other people too, because I know how much, if I love them this much, I'm sure other people love them just as much, if not more. And it's just a punch in the gut that Apple's like, nah, your only out of warranty option is paying us $300 to get essentially the same thing with the same inherent problems. Didn't sit right with me. Yeah, Accidental Tech Podcast mentioned me once. Podfeet made a blog post, and Podfeet's actually going to have me on one of their on one of their podcasts here in the next few weeks. And then I think there's going to be a little bit talking about my HomePod repairs in an upcoming Verge podcast about Right to Repair. It's like I've always been into basically taking someone else's trash and fixing it and making it not trash again. I'm the guy that at the office pretty much people give all of their e-waste to. And I've gotten my hands on a lot of really decent hardware over the years just because people were throwing it away or giving it away. Not all of it's even broken. Some people are just, oh, it's old, I don't want it anymore. Got a new one. And, you don't always have to have the latest and greatest to give yourself a decent experience in the first place. Like a 4 or 5 year old PC is going to bring you a lot of benefits, and it sure beats a kick in the pants. So I don't know. I don't have any new PCs either. All my stuff's like at least 5 or 6 years old, if not older. My cell phone is the only exception, and that's because my day job actually pays for it. Okay. Let's give this a quick sanity check and make sure everything is put together right. What do we got?
I'm having trouble connecting to the internet.
Very good.
I'm having trouble.
And very good. So, this one should be good to go. Like I said, we're going to leave this plugged into power overnight to make sure it doesn't fart on us still. But that brings us to number 3 from Damon. Now this one might be a little interesting. Now Damon here says that theirs will power on fine, but it will eventually shut itself off. And then the last one here today, I don't know what's wrong with it and I don't know who it's from. So we're going to find out together. But here first, let's get taken care of, or get Damon's taken care of here. Yeah. Okay. Let's plug this into some power and see what it does for us. Oh, there it goes. It shut off. Interesting. And we've got zero watts of power draw. Wow. I can't say I've ever seen this behavior before. Huh. And then if we unplug it and plug it back in, it powers right back on. Interesting. Let's crack this open. I'm going to put a different logic board in here just to start and see if the behavior persists. I was expecting that we were going to have to sit here and wait like 20-30 minutes for it to power off. No, that was fast. What could it be? Ooh, it could be the display too. Maybe the display is damaged somehow. take a few days to ship. I'm home on December 4th. Let me put a sticky note on your box now so I don't forget that, because otherwise I'll end up shipping it out the next day here. Okay, so I'll take a look at how long it'll take to ship to you, and then I will ship it out so that it's delivered no sooner than December 4th for you. Let's see, yours is that one. Yes, cool. Okay. Okay. Let's get our good logic board here. See what it does here. I'm hoping, and I'm doubting it, but I'm hoping that there isn't a software issue going on here, because that would be the only thing we can't fix here. But the fact that it pretty much boots all the way up and then suddenly dies is quite strange. Oh, do you see that? Oh, well, that I could care less if we got to replace the amplifier and we can't repair the amplifier. I would rather replace an amplifier than tell someone that we can't fix their logic board issue. So good sign and good news is their logic board is still good, because our no good display and logic board here is still doing the same thing. So that is quite interesting. What is going on with the amplifier that is causing this then? Oh boy, we've got a stubborn one. Yeah, it's not coming up. Not coming up at all. Yeah. Eat my big fat flathead. That one worked me out. Hey, welcome to the stream. Thank you for watching. Alright. Let's just do a quick woofer check. Looks good. Feels good. Smells good. Alright, amplifier is out. let's do a visual inspection here. Our diode has a date code of 1726K, so I don't have any reason to suspect that's having issues there. Everything else looks fine too. Let's go ahead and see if this powers up with a different power supply. Oh, it's still turned off. So it's definitely a problem with the amplifier somewhere. Let me grab my thermal camera and we'll see if we can't find anything weird. The fact that it's got no power draw now, though, I'm doubting we're going to see any kind of short. Everything looks okay. What about the other side? No, everything looks good on both sides of the board. Oh man, this is strange. I wonder... I doubt we're going to have any shorts on here based on the lack of power draw, but let's go ahead and just poke around here, see if we find anything obvious. Oh. Really? Really now? We've got a date code on that diode of 1726K, and yet oh, well, now it's not. It was. I'm kind of tempted to replace this diode. Yeah, let's go ahead and just do that. Because that was strange. Alright, let's see what this does. I'm going to be surprised if this fixes it. But at the same time, I'm not sure what to make of that diode behaving the way it was. No, and it still powers off. So I wonder if it's got something to do with the power for the amplifier, because the power or the logic board boots up just fine. And the amplifier doesn't actually wake up until you do something to the HomePod after you've powered it on. So I'm curious if we wait a few seconds. Yeah, that confirms my theory. Okay. This is where having schematics would be incredibly useful, because then we could find out, well, we have other ways to find out, but it would be easier to figure out where we can inject voltage to this amp and find potentially what is shorting out. Because that's what I suspect here. We probably got some sort of short or malfunction on the amplifier, where the amplifier gives itself power, because the logic board boots up just fine and everything stays powered on for as long as you don't touch it, and then as soon as you touch it, it wakes up the amplifier, and then it shuts off. Quite a unique problem, to say the least. And I don't have a clue. Well, so what else is strange is I normally hear these capacitors charge up every time we power these on, but this time I'm not hearing them. So We're just, we're in, what's the word here? We're winging it here. We're just poking around, taking random resistance values, seeing if we find any differences here. One thing I did find a little strange was how discolored this cap here is compared to what I normally see them looking like. Yeah. Yeah, it still reads 0 there. That's strange. I heard the capacitor squeal, so I wonder if this little cap here did it. That's gonna be real strange. Nope, didn't do it. Alright, We're gonna need to spend some more time on this one. What I'll probably end up doing is taking the amplifier from another HomePod that I've got on the shelf for parts and putting that into Damon's HomePod here so that they get themselves a working HomePod again, and I've got a little more time to figure out exactly what's going on with this amplifier. Quite a strange issue. Okay, so Damon, sir, hang tight. We're gonna, after the stream here today or tomorrow, I'm gonna break down another HomePod for parts so I can get a good amplifier for you, get that put in, and then we'll be able to ship your HomePod back to you tomorrow, or at least as soon as tomorrow. So with that, let's go ahead and move on to this last repair for the day, our mystery pod. The one that we're not sure where it came from or what's wrong with it. I'm going to go ahead and put all of the screws for this HomePod away here so we don't get them mixed up. Yeah, of course. It's my pleasure. My pleasure working on this stuff. I'm sorry we couldn't figure it out here and now, but it's definitely got us stumped for now. But I like a good challenge. And if these HomePod repairs weren't easy to figure out, or if they were easy to figure out, then we probably wouldn't be here. There'd probably be many other people that have already figured this stuff out. So we don't know who this came from. We don't know what's wrong with it, but we're going to go ahead and plug it into power and see if we can figure it out. I'm going to go ahead and guess we've got no power here. And sure enough, we got no power, no response whatsoever here. Considering how clean the top is and the way it was packed, I'm going to hazard a guess this might be an eBay HomePod that somebody bought and had shipped directly to us. But I'm not sure. So we're going to go ahead and get it fixed anyways, and then we'll figure out whose it is later. Okay. Yeah, I figured as much. Here we go. Yep, that is a dead diode, so let's get that replaced. All right. Let's test. All right, we've got power. Now, do we have any DC offset? Ooh, very nice. Nope, we've got essentially 0 DC offset, so this amp is ready to go. I noticed this subwoofer was a little bent, so we're going to find out in just a second here if we're going to need to straighten that out or not. Which was most likely the rather small box that they used to ship this that causes this sort of physical damage. But maybe, just maybe, it's still good. We're going to find out. Nope, it still seals, so that's still good. We will proceed with reassembly. All right, let's see if we are ready to roll. Drum roll, please. Yeah. All right.
I'm having trouble connecting to the internet.
Very good.
I'm having trouble
Give me those volume buttons.
I'm having
Whoa. All right. So, mystery HomePod is fixed and ready to rock. And it looks like we wrapped up sooner than I expected. So I think what we'll do, I've got a bricked HomePod here that presumably has a totally functional amplifier board. So we're going to go ahead and tear this one apart to get that amplifier, and we're going to put Damon's HomePod back together. So before we do this, I just want to double check and confirm that this does indeed have the blinkies still. Which is really unfortunate because this thing is in flawless condition otherwise. It's even still got the plastic on it. Yeah, it's gonna show the blinking volume buttons. I'm not gonna wait for that. It would have booted up by now. Sad. Put that in the pile of bricked boards. Thanks, Apple. Get out of here. We're going to give this board a new diode, just for good measure, but I want to check it for any DC offset first as well. All right, no significant DC offset there, so we'll just freshen this board up with a new Schottky barrier diode, and then we'll put this amplifier back into into Damon's HomePod, and they'll be all ready to go. Let's get that replaced real fast. All right, let's put this pod back together. right, folks. Let's see if we got Damon all taken care of.
I'm having trouble connecting to the internet.
Very nice.
I'm having...
And all checks out. Folks, we got all the HomePods sent in today all fixed up. If you have any questions about any of the repairs that we've done today or HomePod repairs in general, you're welcome to leave a comment down below. I've also got a wealth of information up on my website, nixfix.com, with a section for common issues. All of the issues that we repair here on the channel are covered there, including steps to diagnose and repair those issues and any parts and part numbers that you may need to do those repairs. If instead of doing your own repairs, you'd rather send it in to be repaired here on the channel, I've got my contact info also up on my website under the mailing address. Feel free to drop a like while you still can and while it's still free on YouTube, and subscribe if you like this kind of content. I'll catch you guys in the next one. Goodbye.